Welcome to this video on how to build an LED lighted stained glass display box. When I did my first project, I had some specific goals in mind. I wanted to design an LED lighted wood display box for a stained glass panel. I wanted to use an LED strip light. I wanted the wood box to be made of red oak. The LED would be 110 volt powered. The wood box will be mounted on a wall, and the wood box will be designed so the stained glass panel is removable for installation and repairs. I also wanted the box to be designed so the LED strip light could be easily replaced for maintenance. Before I designed my box to display my stained glass panel, I decided to search the internet and see if there were some guidelines out there for how to design and build such a box. First place I went to was YouTube videos, and I did find a lot of YouTube videos, but they were all for making light boxes for tracing work or tracing patterns. They were not for displaying stained glass artwork. I then searched and posted on the Stained Glass Addicts Facebook group. I found nothing for display panels searching that users group. They did have a lot of things about light boxes for tracing, but not display work. So I made a post, said what I was going to do, and the only thing I got was a couple comments on the diffuser material, and we'll talk about that later. When I searched the internet, I only found one website. It's called northernhardwoodframes.com. I have utilized this website before because they have some pretty neat stuff for hanging stained glass artwork, including hooks and chains, etc. They will also sell you the wood to frame your stained glass panel, or they will actually go ahead and make the wood frame for you to fit your stained glass panel. But a new thing I didn't know they offer lighted wood display boxes. Here's a screenshot from Northern Hardwood Frames website, and I've circled in red. You can see the custom light box frame in the upper right, and in the lower left you can see they sell light box kits. So once you go into their website on the details about the light boxes, you find out they will sell you the wood so you can make your own light box, or they will make you the light box themselves. However, their light box does not include any lights, and it does not include any type of diffuser panel. On the website of Northern Hardwood Frames, as you can see here, they explain to you how they make the lumber for you to make your own light box or a light box they will make. And you can see one of the side pieces of the box shown here, and it's kind of what you'd expect in that the stained glass panel, they have a slot cut in for the panel to slide into, and then they have a second groove behind the stained glass panel groove, which is for their diffuser panel. And then if you notice the LED puck light, they say that you can drill a cord in the box and install your own LED puck light. So a puck light is a round, couple inch round diameter LED light. It's not the same thing as an LED strip light. So with respect to the diffuser panel shown on the Northern Hardwoods website, I did an internet search for that, but I really didn't have any luck finding what material one would use for that diffuser panel. So my simple idea was, why not just use the diffuser from a 2x4 fluorescent panel? So I went to my local Ace hardware store and I selected a diffuser that you can cut. It's more of a plastic, softer plastic material. When I posted that on the Stained Glass Addict group, one of the members said my fluorescent diffuser would not work. And then a different member on that group said they would sell me a piece of their special diffuser material, but when I asked, I could not get a response on what type of material he was using or what the source was. Another member said that she placed quilting batting material over the LED lights to act as a diffuser. So this drawing shows my initial design concept. looking at how the grooves would be made in the sides of the wood box. The front panel would be the 1/4 inch thick stained glass panel. It would fit into a 5/16 inch wide groove that's cut about 3/8 of an inch deep. That gives you a little bit of allowance there if things aren't quite square. Then behind the first groove is the second groove for the diffuser panel. Now I was going to try out my 2x4 fluorescent drop-in in this groove, or if I found another material I could try it in that groove also. So I made that groove an 1/8 inch thick and made it also 3/8 deep. So here's an overall view of my initial design concept. My stained glass panel is actually 12 inches wide by 20 inches tall, and when you use 3/4 inch stock for the sides, that works out to dimensions of the wood case of 13 by 21. I made it 4.5 inches deep, primarily because I needed to fit the light switch in the side, and you can see the switch cover plate and the button on the right. Sticking inside the box then would be a typical blue plastic 110 volt electrical box. You can see I'd have the stained glass panel 12 by 20. Inside of that would be the 1/8 inch thick diffuser material, and then I would put the transformer box inside of the wood box also. That was my initial plan. Now, since I've never built a wood box with LED lights to display a stained glass panel, I decided to make a prototype wood box out of inexpensive, cheap, common pine. That way I could develop the design, get something that works, and after I got it working, then I could build the final box from more expensive red oak. Now for the box itself, I used 45-degree angles at the 4 corners. On the bottom 2 corners, I glued and screwed those. They should never have to come apart. But in the top, I did not glue those. I just used screws. Now in red oak, because it's so hard, you have to drill pilot holes first. Then I use a bar of paraffin and rub it on the steel screws, and then use the steel screws to basically cut the hole in the oak. So which means you've got to screw and unscrew each one of them 3 times before they go full depth. But once you've done that, then you can put the brass screws in, and you won't damage the screwdriver slot on the brass screws. And you do that after you have the staining and polyurethane done. Now on the back, I used 1/4 inch thick plywood, and I attached it with screws so it could be removable as well. For my LED strip light, I went on Amazon and did some searches, and this is the one I selected as shown in the picture. It's 16.4 feet long, includes a power supply and a dimmer. There's 300 LEDs or little chips, and the cost was $16. So before I actually received the LED strip lights that I ordered from Amazon, my initial thought was I would mount those LED strips on the back panel of the box, which is a thin piece of plywood. Then the lights would be shining directly out through the stained glass panel. So to do that, I would have to mount those LED strip lights in kind of a serpentine pattern, as shown in the picture here, a crude diagram. However, when I received the LED strip lights, I quickly figured out that concept won't work. The LED strip is more like a 1/4 inch wide piece of masking tape. So if you tried to put masking tape on the back of this wood panel and then try to make a 90-degree turn, it just won't do it. It just won't bend that way. After I figured out that you cannot bend the LED strips at a 90-degree angle, I got to wondering if they make plug-in 90-degree connectors, and that would let you make the serpentine loops on the back panel. So you'd run a straight piece up to the top, then you'd have a right angle connector, and then put another right angle connector, and then run a straight piece back down to the bottom and repeat that. But when I went on Amazon and I did some searching, they do make some plug-in 90-degree connectors, but most of the customers said on the reviews they were terrible quality, and most of the users ended up having to solder the connections because the plug-in connector was just too unreliable. So I wanted something extremely reliable connections with no soldering required. So after I thought about it a while, I thought, why couldn't one just wind the LED strips around the inside walls of the box, kind of like a spiral pattern. That way you'd have no connectors required at all, and about 3 loops would fit in there fine. So to temporarily try out the idea, I just used blue masking tape to hold the LED strips in the right position. As I started to work with the LED strip tape, it's designed so you peel off a paper backing strip, and then the sticky material is supposed to stick to however you apply, or whatever material you apply the tape or the light strip to. And in the past I've had terrible luck with those type of adhesives sticking for months and years without coming loose. So I did an internet search, and I found out they make a special plastic staple that has screws, and they're made just for these type of LED strip lights. So I did some more internet searches, and I found plastic clips that are specifically made for anchoring or mounting LED strip lights, as shown in the picture above. They also have screws to give you a secure connection that won't come loose like that peel-off tape will. So I ordered several packages of these, and they work very nicely. Here you can see that I've got the LED strip lights pretty well completely installed. The 16 feet of material gave me enough to make about 3 times around the inside of the box. And as you can see, I put some plastic clips on the outer ends and then some in the middle. And hopefully that will retain the strips in place for many years to come. My third major finding doing the prototype box was I ran some tests, and the 2x4 foot fluorescent diffuser panel really did nothing at all in terms of diffusion. And I measured that by the naked eye and also by using my digital camera. The fourth finding that I had doing the prototype work, that installing the blue plastic light switch box and a black transformer inside the lighted wooden box would not work at all, because you can see the blue color through the stained glass panel and also the black color of the transformer. It also blocks the lights that's being emitted from the LED light strip. So I changed plans and decided to locate the transformer and the dimmer outside of the wood box. So at the start of the LED light strip there's a pigtail connector, so I drilled a 1/2 inch hole in the bottom of the box, and I ran the pigtail out the bottom of the box, and then later the dimmer and the transformer can be plugged into that pigtail. The fifth major finding from doing the prototype work was that my digital camera photos will show the LED bright spots where the little chips are, but your naked eye cannot see them. Rather interesting. The sixth major finding was involving the quilting batting material. Now that batting material is typically about 3/8 of an inch thick when it's uncompressed. What I found from my test work was the more layers of the batting material you add, the more diffusion you do get, as will be shown in an upcoming photograph. So I ran some experiments once I had the LED light strip temporarily installed with blue masking tape. The first one I put in my 2x4 diffuser from the fluorescent light. It had no impact at all, and that is really what's shown on the far left photographed. However, the digital camera, you can pick out the LED little light dots or spots in the green border glass, particularly at the bottom and on the right hand side. So then I took 1 or 2 layers of the quilting batting material, and I just wrapped it around the inside of the box. And in this case you can see there is some diffusing, because on the bottom green 2 panels you can just barely see the little light bright spots there, and then on the right hand side you really don't see any at all. So then I went ahead and I added 3 to 4 layers of quilting batting material, and as you can see on the right hand side photograph, it does a pretty good job of completely diffusing the little bright spots, at least as measured by the digital camera. So with respect to the quilting batting material, as the woman said in her comment on the Stained Glass Addicts Facebook group, The quilting batting material placed over the LED chips does diffuse or diffuse the bright spots. In my case, the LED bright spots were not obvious to the naked eye, although they showed up in the digital camera. And I always like to follow the KISS principle, keep it simple, stupid, and I was concerned with the quilting material falling down over time inside of the box. Now there's some options you could use to secure the quilting batting material, keep it in place. You could use staples, however, staples are pretty tough to penetrate the hard red oak that I use for this box. Plus you'd have to be careful and not hit the LED strip with a staple and make an electrical short. You could use hot melt glue, but I have trouble trusting hot melt glue to many years of time to hold up. And it could be possible to use those same LED plastic clips with the screws in them. You could put those over the quilting batting material and possibly use those to securely hold it into place. Now here is my temporary testing setup. I've wrapped a couple layers of the quilt batting material around the inside of the box, and I have to remove the top wood piece of the box so that I can have access to put in the quilting batting material. And once I have it in there, then I'll slide the stained glass panel down into the grooves, and then I'll place the wood piece on the top of the box. This is how I did my testing with the quilting batting material. The back board, the 1/4 inch thick plywood, is painted white, so it doesn't stand out real well, but you can see it in this photograph. So once I completed all my prototype testing and I had the final design, I went in and updated my Google SketchUp drawings in my drafting program to show the final design. And in this case, you can see the pigtail wire that's coming down from the bottom of the box from the LED light strip. And then the end of that gets plugged into the dimmer switch, which in turn gets plugged into the transformer. This updated drawing shows how I wound the LED strip around the inside of the box 3 times. Just shown as a simple white strip here, and then of course they were held in place with those special plastic clips and screws. And also shown is the connector pigtail, where it comes out of the strip and then goes down my 1/2 inch hole at the bottom of the box, and then eventually will get plugged into the dimmer and transformer. So here's the finished project. On the left you can see the red oak that I've actually stained to a golden oak stain color, and you can also see the brass screws on the right hand side as well. Then once you turn on the LED lights to full strength, this is what you see, the photo on the right. It came out very nice. This project was quite a learning process. So on the next 2 tables I've attempted to summarize what I found through the prototype and testing work on this project. On the left hand column is my original design concept, and then as a result of the test work, what I ended up using as a final design. So initially I wanted a blue plastic electrical box on the side of the wood box and put the transformer inside the box. That didn't work because the blue plastic box showed up as blue and blocked the light, and the transformer would have shown up as black and blocked the light. So I ended up with an LED strip pigtail running out of the bottom of the box to the dimmer and transformer. My original idea was to use a 2x4 foot fluorescent light plastic cover as a light diffuser. In my test work, as measured by the digital camera, that had no impact at all in terms of diffusion. A lady mentioned to use quilting batting material as a diffuser material. That on my project, I decided I really did not need any diffusing, but the testing work indicated that 3 to 4 layers of the 3/8 inch thick quilting batting material does act as a good diffuser. I just didn't know of a secure way to mount it so it does not fall down over time on my project. Plus I didn't need it. Turns out you do need it. I think you could figure out how to mount it securely to hold up for a long period of time. Now my stained glass, I used hammered or textured green glass on the outside border versus a plain green, which actually turned out to help diffuse the LED lights. I also use ice textured clear glass for the sky because I didn't want to be able to see in the box and when it was not lighted. So the hammer green actually was a good diffuser of the LEDs. I am very likely, I think, if I'd used plain untextured green glass, they would not, and I would have had some little bright spots in my panel. My original idea was to mount the LED strips on the back board in a serpentine fashion. That did not work because you cannot make 90-degree turns with the LED strips. So what I did, I wound the LED strips around the inside of the box. But at that point I couldn't, I couldn't find any reliable 90-degree non-solder connectors, so that's why I wound it in a spiral fashion. On my original design concept, I thought I needed to provide some heat ventilation holes in top of the wood case. After I got all the work done though, the transformer ended up being outside of the box, which is the real heat generator. The LED light strip generates very little heat. But I went ahead and I drilled 2 1/4-inch diameter holes in the top of the wood case just to be on the safe side. I also was not sure how to mount the LED strips. I found out the peel-off tape method didn't work very well in my application and has not worked well for me on past applications. So I did find a plastic screw with a plastic clip that uses a screw that is specifically designed for these LED strips, and it worked very well. I assumed the bright spots from the LED chips would show the same to the naked eye in a digital camera. I found out the naked eye is less sensitive to showing the LED chip bright spots versus a camera. Kind of surprising outcome. I thought I could discover a 1/8 inch to 1/4 inch thick diffuser panel material that would let me use any stained glass panel in a lighted box with no LED chip bright spots. I've been unable to discover such a material at this time. I emailed Northern Hardwood's website. They suggested a frosted glass or a security glass from a hardware store. However, I went to my local Ace store. They don't carry either one. All they carry is a film that you would put, a frosted glass film that you would put on an existing bathroom shower. So I still haven't found that mystery material yet. So to summarize this project, I hope that my results will help you if you decide to build your own LED lighted stained glass box. LED technology is constantly changing, so who knows, in the future there may be better components to use in these type of applications. So thanks so much for watching this video. If you'd like even more information on my LED stained glass display box, you can see my website. I'll put the link in the comments section. Thank you.